Hello, welcome to By Excellence Tutorials. And in this video, we are going to solve a question from thermodynamics. Okay, so a sample of ideal gas is expanded to twice its original volume of 1 cubic meter in a quasi-static process for which a pressure is got alpha V squared, with alpha being equal to 5 atmospheres per cubic meter. How much work is done on the expanding of gas? Okay, so in the first place, we have pressure. We have pressure being equal to that. That's what we've been given. And then we have initial volume, V1, being equal to 1 cubic meter. And then we've been told as well to say this ideal gas has been expanded twice its original volume. So meaning the final volume is twice the initial volume, which is 2 cubic meter, like that. Okay. So this is the data that we have. And then we can be able to say, now, how do we get the work done? So work done, so this is a quasi-static process. So we say the small change in work done being equal to P with small change in volume, because it's volume that is changing here. Okay, so we can substitute where there is pressure with what we've been given. So we have small change in work, alpha V squared, change in V. So you can see that this is a differential equation. We can now introduce the integrals, of which here it's coming from 1 to 2, and then the initial V1 to final. Those are our limits. So here, once we differentiate, we are going to have work. So I will say 1 to 2. Okay, so it's starting from 1 to final, the initial to final position. Giving us, we factor out that, because that's a constant. And then we have V1, V2, change in V. So we integrate this, and then we are going to have, here we are going to have 1/3 V cubed with the limits V1 and V2 and V1. So we have 1/3 alpha and V2 cubed minus V1 cubed, like that. Okay, so now we can plug in the values where we have 1/3, and then alpha we have 5 atmosphere per cubic meter. And then we also have V2 is actually 2m cubed, and this is cubed minus 1 meter cubed, like that. So our once we punch, we get 35/3 hm per cubic meter, and this is going to give us 2 cubed is 8, and m cubed, that will give us okay, that will give us 6. And then once we do the multiplication, we get 7 That's 7. Yeah, 7, 6, like that. So we have our work. So once we punch this, we get 11.667, and the units here are going to be atmosphere. No, so the cubic meter is going to cancel there. So we have atmosphere, cubic meter, like that. So you know that work, we can't leave work in that with those SI units. So we can convert atmospheres to joules, of which we know that the conversion factor is Pascal, giving us 1 atmosphere. So we have equal to 1667 atmospheres. Okay, and then we multiply by 1325 Pascal. Okay, so we get okay, so there's a negative here, sorry, there's a negative. And this SI unit is giving us joules. So work done from initial to final, or work done on expanding this gas is going to be negative. So we can say 1.18 gigajoules. So this is how we calculate for that question. So if you have found this video helpful, you can like, share, and comment. And if you have not yet subscribed to the YouTube channel, kindly subscribe, and don't forget to click on the notification bell so that you get notified each time I upload a new video. Thank you so much for watching.